Okay. Hi, I'm What's-His-Face. You've seen me in a number of fine quality, epic AP Chemistry educational videos such as Why Am I Doing This on an Early Friday Morning? And Dedication. That's what it takes to be a member of the Imperial Guard, Part 4. Okay, last week I talked to you guys about bond energies, and I gave you guys an assignment, and as you were going through breaking bonds, putting bonds together and all that, I looked at your papers and it's like, something's not right. And so what I decided to do, I looked back and I realized that one, I made a mistake, and two, I'm not sure everybody understood. So what I want to do with this particular thing here, I want to show you guys how to do it the right way. Okay? So we have a reaction here. In this case, and I'm just going to go ahead and write the formula here. It's C2H6 plus Cl2 gets us C2H5Cl plus HCl. So that's the equation that we have. So now what we're going to do, we're going to go ahead and we're going to tear the thing apart and then we're going to rebuild it. One of the things that I did not do, and I went wrong on this, was everything has to come apart, even if when they're coming back together again, it's as if they never left. That's where I went wrong. And I am sorry about that. So I want to go back, and here, this is where when you look at an equation like this, you want to put the Lewis structure in there. Now, do you have to put in the little dots? No, just those dashes. As long as you know about double, single, triple bonds, if they're there, that's a key component. So let's go ahead and we're going to look at it. Now you've got the bond and the enthalpy here. That's given. Now I'm going to give you guys the paper so you can actually work through this. Okay? So for every bond that you break between a carbon and a hydrogen, the enthalpy, think energy, is 413 kilojoules per mole. Now that's if you break it, and that's going to be negative because, well, for our purposes here, we're going to keep everything positive because we do have that overall formula, right? So if you break it or you put it back together again, it's 413 kilojoules of energy for every single mole of the C and the H that come together or they break apart. Now remember, don't worry about the negatives right now. All that the negative tells us is which direction is the energy going in. Okay? And we'll get to that. So the question that they're asking here is, what's the total energy per mole? It's A, 580, B, negative 114, C, 233, or D, negative 453 kilojoules per mole. Okay, quick pro tip here. Whenever you get a negative kJ per mole, that's an exothermic reaction that has taken place because the negative indicates the energy's going out. But we don't know about that right here, right now. So let's tear this apart. Okay, well, I'm going to go back and I'm going to look at this. Now, how many bonds are going to be broken? Well, I notice I'm going to break one carbon-hydrogen, two carbon-hydrogens, 3, 4, 5, and 6. So that's 6 carbon-hydrogen atoms I'm going to break. Okay, so I look under here for CH. I've got 413. And that means I'm going to need 6 times 413. There. Now, I go ahead and I were to multiply that out. Well, let's not multiply it out yet. So I know I got 6 of these. Now, here's the thing though. What I didn't, and this is where I went wrong. Guess what? Even though the carbons in the product side, it's as if they didn't move. we counted that those carbons break as well. So we have a carbon-carbon breakup, which is 347. So we'll have only one of those incidents, right? Only one with 347 kilojoules per mole. So this is looking at the hydrogen-carbon connection. And there's 6 of them because we counted, right? Then there's only one incident of carbon-carbon, and that's right up here. Okay? So far, so good? Of course. Any questions? Sorry, I'm not here. So with that, I'm hoping you guys would see what's going on. Now, we also have on our reactant side the Cl2. Now, the Cl2 does also break. Okay, we know that that's going to break as well. So let me mark that off with a blue. Okay, and let's bring that down here. So the value of the Cl is 239. So I got 1 times 239. So this is what's happening here. This is the energies that are involved in being broken up. Okay? So this is the energies involved in being broken up. So let's go ahead, let's add those, and then, well, yeah, let's add those together, okay? And get that out of the way. So I've got 6 times 413 equals 2478, okay? Plus 347 equals, plus 239 equals, so I have got 3,064 kilojoules of energy per mole of all these things broken up. So when we look at this side here, it's 3,064 kilojoules per mole. Okay? This is the total on our reactant side. That's the total. Okay? That's the thing. So that's the total. Now we need to look on the product side. Let's look at the product side here. Now what's happening here with the product side? Well, we've got things that are being put together, right? So even though I told you originally, hey, this doesn't change and therefore you don't do it twice. You have to, we broke the carbons. Now we have to put the carbons back together again. And some of you guys might be thinking, well, wait, doesn't it like cancel each other out? Yes, but we still need to do it that way. So I know I have a carbon-carbon, okay, and so I know that I have 1 times 347. That gets my carbons back. That's my carbon-carbons coming back together. Now here I have, for the hydrogens, notice I've got 1, 2, 3, 4, 5 of these hydrogens. Well, I know that one of them is 413, so that's going to be 5 times 413. That's the carbon-hydrogen. Okay? Now we have a couple of new things here because we also have a chlorine that has been attached here to this carbon. So let's look at the chlorine and the carbon. We look up here on the chart and it's, oh, hey, look, it's 339. Okay? So it's 1 incident times 339, and that is the chlorine joining up with the carbon, like that. And notice I'm writing out where those energies are coming from, so that helps you keep track. Now, when you guys are solving your problems, even on the AP exam, if you need to do this, do you have to show where those energies come from? No. I'm showing it to you for the purposes that you could keep track. Okay? All right, so we got everything except the HCl. Now we only have one of those, right? So what's the HCl? That's 427, so that's going to be 1 times 427, and that happens to be our HCl connection. So this is what we've got right here, right now. This is what we have. Okay, so we're going to need to add that up. We've already figured it out for this side. Now we need to add this one up, and we're going to use the calculator for it. Let's clear it. So I have 5 times 413, that's 2,065, okay, plus 347, plus 339, plus 427 equals, and I have 3,178. Great. So we know the energies that are involved with the reactants breaking up into their pieces, and we know the energy involved in putting pieces back together again, but definitely not quite the same way. So this is what we have. Now, what was the formula? Okay, well, the formula is the delta H of broken bonds minus the delta H of bonds formed. That's a very important formula for you to use because you will be using that in other ways. Okay? So I'm just pointing that out to you guys. Okay? All right. Newt, wake up. I don't even want to hear the whining from Mark. Not at all. You've got nothing to say here. Okay, let's finish this. So I'm going to take this down here. This is the broken bonds, and this is from the bonds that are formed. Okay, we went through all that. Now I'm going to go ahead and I'm going to say 3,064 minus 3,178. Yeah, the math is relatively simple. It's just putting together the pieces, take them apart, put them back, figuring out how much energy it's going to take. Because this is what it's going to be. All right. So looking at that, we are going to have, let's clear this, so 3,064 minus 3,178 equals negative 114 kilojoules per mole. So what does that tell us? In this reaction that's happening, you're going to get, for every mole of stuff that you're making, you're going to get energy being released at about 114 kilojoules. Because remember, the negative, it's not a bad thing, it's telling us the direction. It's telling us it's going outward. Yeah, just like in those rapping videos. Yeah, you know when they do that stuff, tricky stuff with the camera? Yeah, watch the boomer do it. Yeah. Okay, that's it. That's all that it is. Now let's go back up and let's see. Is that negative 114 there? So here's our total energy per mole. Okay, we got our negative. Oh, here we go. It is, in fact, ladies and gentlemen, choice B. That's it. Now, I'm going to give you a fresh set of papers, okay, and I'm going to have you take a crack at it one more time because Wednesday I'm going to give you a quiz on it, okay? And I would expect you guys to be able to work with that. Okay, without further delay, I'm going to stop here. Grandmaster C signing off. Take it easy. Oh yeah, go Lancers.